How's it going, Eliminators? Today we're going to be looking at a Husqvarna Riding Lawn Mower that came into the shop with a dead battery and my customer said was hard to start. It could be an electrical issue or it could be mechanical. Either way, we're going to go through and diagnose it. So with that being said, let's get right into it. So my customer called me up a few months ago and said my riding lawnmower will not start. Seems like I have a dead battery. Can you come over and have a look at it? So I brought this to his house. This is a Moto Master battery load tester. Basically, you hook up these two alligator clamps there, and then you depress this button. And what that does is puts the current through a big resistor there, putting a load on the battery, simulating the load that a starter would put on it. And what you're looking for is when this thing is hooked up, you want the volts to be around 12.75. Then you guys can see there when it's running, the charging system puts it anywhere from about 13.5 up to around 15 volts. That lets you know your charging system. So the magneto or alternator under the flywheel, as the magnets go around it, they send a little bit of current back to the battery to trickle charge it. And then when you depress this button, it puts that load on the battery and you'll see the needle drop from wherever it was, 12.75 down to maybe 12 volts. That lets you know that it's okay. If it goes around the 10 volt area, it's weak and your battery probably will need to be replaced at some point in the near future. And if it goes down to 9 volts or lower, then your battery is bad and needs to be replaced. Now, the battery that came with this Husqvarna riding mower when my customer bought it was a 230 cranking amp battery, and over time batteries need to be replaced. So I put the load tester to it. Sure enough, it showed as a bad battery. So I said, go and buy a 430 cranking amp or a 350 cold cranking amp battery. When it comes to riding lawnmowers, you basically want to put the biggest battery you can into your riding lawnmower, regardless of what kind of engine you have. It'll just help prevent battery issues in the future. So just like I said, my customer went down to the local parts store and purchased the 430, which is going to be the 350 cold cranking amp battery. Installed it into the riding lawnmower. Sure enough, it worked perfectly fine until a couple months later. He gave me a call just yesterday and said, you got to pick this thing up. My riding lawnmower won't start again, and I think the new battery is bad. So you guys can see that I have the Noco Genius 10 amp charger. I wanted to charge this battery because I want to load test this battery, and we have to fully charge it first. So I've had this battery charging for a while now. We are under 12.75 volts. You guys can see we're about 12.25 there. So what I'll do is I will depress this button, and you guys are going to see that the battery goes to weak. Now, you don't want to leave that on too long, but if I leave this battery charging for long enough, we may be able to repair this battery. However, I need to diagnose why this battery lost its charge and would not start the riding mower. Now, without getting too technical and spending a whole bunch of time talking about it, because I do have a video specifically for that subject called Complete Electrical Diagnosis of a Riding Lawnmower's Electrical System. I'll link it in the top right of your screen as well as in the description down below. So you guys can see that I have the battery box out. In that electrical diagnostic video, I show you exactly how to resistance test pretty much every wire that you would need to test on a riding lawnmower. So I did just that. I started at the battery ground. That was good. I checked the battery positive from the battery to the starter solenoid. That was good. Then I checked the long starter cable that goes up to the starter. Resistance was okay on all of those cables. So we have a good ground, we have good cables, we have low resistance. There must be an issue somewhere other than the connections and the cables. Now, in this particular riding lawnmower, once you pull out the battery and the battery tray, the starter solenoid is going to be located here, and it is bolted to the frame right there. So I just removed the bolt and removed the starter solenoid. So I have two identical starter solenoids here on the workbench, and they both work. Now, I do have a whole bunch of electrical testing stuff on the workbench, and I'll briefly take you through some of it. I do have a video on how to test a starter solenoid, but for today's video, we're going to be focusing on one specific thing, and that's going to be resistance testing the terminals between the battery positive and the starter. And to do that, we need to charge the solenoid to engage the electromagnet inside of here that raises the bar that makes that connection. If you want to watch that video on how to test a riding lawnmower starter solenoid, I will again link it in the top right of your screen as well as in the description down below. But for right now, I'll be going over exactly what you need to test something like this. It's quite simple. I have a 12-volt lithium-ion battery pack here that are sold on Amazon and eBay as a car jumpstart pack, even though I would never use one to jumpstart a car because these cables are very thin and can be overloaded quite easily. Even though the 12-volt positive cable here is fused, I've seen these things completely burn out and melt cables, so I only use them as a source of 12 volts for testing electrical components like this on my workbench. So 12-volt source, we have the connections here that have medium-sized alligator clips, and I have a 10-foot retractable test lead kit made by Lang Tools here. Now, I bought this on Amazon. I can put a picture up on screen. It was relatively inexpensive, but this thing has come in super handy because of the long wires that you get, and they all have alligator clips. There's a green, a red, and a black one. I primarily use the red and the black, positive and negative, to extend whatever it is that I'm testing, whether I'm doing a voltage test or a resistance test, or whether I'm trying to charge something, which we're going to be doing today with these solenoids. So first up, I want to show you that the old solenoid works every single time. So what we're going to be doing is a resistance test between these two connections. In order to test the resistance, though, it needs to be fully powered. So we're going to hook this up and we're going to go over to our multimeter, and we're going to be setting our multimeter to 200 ohms of resistance, which will test under 200 ohms of resistance. If you think the resistance might be greater than 200 ohms, you'll want to turn it up to the next position. And in this case, it goes to 2000. So what I'll do is I will touch the two connections there, and we're looking for resistance, and you guys can see it's bouncing all over the place. It's definitely over 100 and is spiking up to around 150 ohms of resistance. Again, because we're testing at the 200 level, you guys can see there it is dropping to 90, but we're getting approximately, I would say, an average of around 140 ohms of resistance. So the question now is, what should a brand new starter solenoid test for resistance? Well, I have a brand new one here, as you guys saw at the beginning of the video. So we're going to be putting this one to the side. That's the one we took off of the riding lawnmower. We're going to be doing the same thing, powering the solenoid, and then we're going to use the multimeter, and we're going to be resistance testing this one to see what the results are. And just to prove that this one works, again, it's brand new, so it should. So I'll hook this up and bring you back. Okay, so I got this one powered and we're hooked up to the multimeter here. Once again, same 200 ohm setting, and we are reading 0.6, and that's exactly what it's supposed to do. This thing should have hardly any resistance once it is engaged by your key switch. This is an electrical component. It is prone to failure. This has a metal base. You guys can see that it's riveted, and it has a plastic top. Again, this has an electromagnet in it that raises a metal rod. These will eventually allow moisture inside of them, and corrosion will form. Corrosion and rust leads to resistance, not a good thing. Now, seeing approximately 100 to 170 ohms of resistance on a starter solenoid may not be that big of a deal, so I'm going to start looking at other areas of the riding lawnmower that could be causing a depleted battery. If your battery's magneto underneath the flywheel is not charging your battery while the engine is running, then every time you turn that key switch, you're depleting your battery and you're not putting anything back into it. So eventually your battery won't have any juice left in it to start your engine. And you can see how I tested that on a Troy-built TB30R. I did a complete diagnosis of that issue. Once again, I'll link that in the top right of the screen and in the description down below. Sometimes it's just not worth fixing that issue. So in that case, my customer didn't want to spend the money. He just hooked up a battery charger to his battery after every cut. I should also point out that you never want to disregard the possibility of a bad starter. However, on this particular riding lawnmower, sometimes when I turn the key, the engine would crank over, even with the battery being depleted. Once again, though, we can use our multimeter hook it up positive to the starter terminal, negative to the engine there as our common ground. And just like our starter solenoid, this starter only has 0.3 ohms of resistance. Once again, testing in the 200 range. So that leads us to believe that it is not the starter. One other thing that I'd like to point out that could lead to battery failure or hard starts is the Acr mechanism, which is going to be the automatic compression release system that has been built into the camshafts of these engines. What they do is briefly bump open the exhaust valve on the compression stroke to make starting the engine easier. Now, if that mechanism fails, the engine will be incredibly difficult to turn over. And one of the easiest ways to see whether or not your automatic compression release system is working is to simply remove the overhead valve cover and turn the engine over, whether manually by hand going up on the screen there or using your starter. What you should see is the intake valve fully depressing and then the exhaust valve fully depressing. But on the compression stroke, you should see that exhaust valve move ever so slightly every 4th revolution because this is a 4-cycle engine. Pull this right off. Check that out, guys. Using the heat gun just helps to soften up that adhesive. Don't hit this thing with a rubber mallet or a soft blow hammer, or even try to pry them out with like a flathead screwdriver, because these covers are made out of stamped sheet metal. So you could definitely deform one of them, and then you could have sealing issues in the future if you have a warp in it. So again, heat gun, heat it up, they peel right off, super simple. So with the riding lawnmower up on my riding lawnmower lift here, I removed the overhead valve cover. So now with the spark plug removed, what we're going to do is spin the flywheel in a clockwise direction. And what we're going to be looking for is the exhaust valve, which is right here. So we have the intake valve going back on that angle there. And we have the exhaust valve right next to the exhaust tubing, which goes down to the muffler. So as I roll this around, you guys are going to notice that we are now on the intake stroke because the intake valve is opening up. So we're going to keep rotating this around by hand. And we are now on the compression stroke. Now on the compression stroke, again, the Acr should just bump that exhaust valve down ever so slightly to help release a little bit of compression. And that's what we're looking for. However, you guys can see that the exhaust valve is not moving until we reach the exhaust stroke, which is right here. So we keep rotating that around and we are brought back to the intake stroke. So unfortunately, the Acr, or the automatic compression release on this engine, is broken. Now, your engine may not be equipped with an Acr, so one of the easiest ways to check for that is to simply look on the overhead valve cover, specifically for this engine here, and you will see the model number of the engine. This one is a 33S777-0001-G1. What we're going to do is run that into Google, and we're going to search for a parts diagram. Once you pull up the parts diagram, you're going to click on the camshaft diagram. You're going to want to click on the camshaft itself and get the part number. Then you can Google search that part number and pull up images, and you will see a whole bunch of photos of that camshaft. If you see anything else on that camshaft other than a gear and 2 lobes, that means that it is most likely an automatic compression release mechanism, as shown here with the arrow pointing to it. The way that system works is under approximately 750 RPM, that lobe opens up the exhaust valve ever so slightly on the compression stroke. Once the engine starts and surpasses the 750 RPM threshold, centrifugal force pulls that mechanism out, disengaging that lobe from interfacing with the lifter or the flat tappet that pushes the exhaust push rod. So this engine does in fact have an Acr. Again, we rotated it around, could not see the exhaust valve opening on the compression stroke. Thus, the Acr mechanism is unfortunately broken on this particular engine. Now, in the event that you remove the overhead valve cover, rotate the flywheel clockwise and notice that the Acr mechanism is in fact depressing that exhaust valve just a little bit on the compression stroke. What else could you look for? Well, you would want to check the adjustment of the rocker arms to the valves themselves. And what you should do is set the engine to top dead center on the compression stroke. I have videos adjusting valves. You guys can click in the top right of your screen if you'd like to see one of those, or you can simply rotate the engine until, let's say, the exhaust valve is fully depressed, and now we can check and adjust our intake valve, and then vice versa, rotate the engine around until the intake valve is fully depressed, and you can check your exhaust side. If your valves are not properly set, and let's say there's too much clearance in between the rocker arm and the valve stem tip, what'll happen is as your piston is moving around in the cylinder, when the lobe on the camshaft starts to push the lifter, which in turn starts to push the push rod up and moves the rocker arm down to depress the valve, a greater clearance in between your rocker and your valve stem tip will cause the valve to open at a later time, which can cause hard starting on your engine. Normally these are set to 4/1000ths of an inch on the intake side and 6/1000ths of an inch on the exhaust side, because the exhaust valve heats up and will thus expand a little bit more. So once the engine is at operating temperature, that 6 thou clearance becomes closer to 4/1000ths when it's hot. So essentially what's happened is every time my customer tries to start this thing, even with a fully charged battery, because the ACR system is broken, the engine is a little harder to turn over, which puts a bigger load on the battery, to the point where he is forced to boost it, and using a battery booster or a battery charger pack increases the amperage in the circuit, so that when he turns the key, he now has the amps required to turn over the engine that's harder to turn over because of that broken ACR. So the ACR needs to be replaced. How much could someone expect to pay here in Canada? Looking through the Briggs and Stratton parts portal, we can see that my cost for that camshaft, because you have to replace the entire camshaft, is going to be about $98. And it lists for approximately $131. And you have to understand that in order to replace the camshaft on this engine, the engine has to be removed from the riding lawnmower and the engine has to be disassembled. Not to mention, even if my customer said, go ahead and fix it, that part is unfortunately back ordered directly from Briggs and Stratton. So even if he wanted me to fix it, I wouldn't be able to get an OEM part, and I would be forced to purchase one on Amazon or eBay, which will most likely end up being a Chinese aftermarket one. I did want to mention that Terrell Fixes All has an excellent video going over the differences between the OEM and the aftermarket or the Chinese camshafts that are flooding the market right now. The link to that video will be in the top right of the screen. I can also link it down in the description down below. You guys will want to check that out because there can be some significant differences when it comes to quality. And if you guys are going to be tearing down your engine, you want to spend the money to get the OEM parts. So I called and spoke with my customer. He said it's not worth fixing. So I'm using a gasket instead of RTV silicone to replace this overhead valve cover. So final thoughts on the old Husqvarna with the Briggs and Stratton here with the broken ACR. Here in Canada, these things are just simply not worth fixing. Over in the States, you can get parts for way cheaper than you can here in Canada. My customer doesn't want to spend the money, even if he said he was willing to spend the money, and even if the part was available, which like I showed you, it's back ordered because of so many people having this same issue with this engine. I would have told my customer it simply isn't worth it. As you'll see in Terrell's video, even the OEM Briggs and Stratton camshafts now have parts that are pressed onto the shaft. They are no longer a one-piece solid cast design. These are parts that are simply pressed on, and just like the Chinese aftermarket ones, they'll end up failing and you'll just have to pull the engine apart and replace the part again in the future. This riding lawnmower also has a transmission that has the housing made out of plastic. You guys have probably seen videos on this topic before. I know Terrell has videos on this. These things are absolutely garbage. And one of the first signs that this transmission is starting to fail is you start to lose reverse gear. And when I load these riding mowers onto my trailer, I like to back them in so that I can butt the tires up against the front of the trailer. That way, if they don't have a bumper on the front, I'm not damaging a plastic hood. And when I went to drive this up onto the trailer and pressed reverse, this thing simply did not have the power to go up my ramp. That is the first sign that this transmission is already starting to fail. Sooner or later, my customer will completely lose reverse gear and he'll only be able to drive it forward. And not long after that, the transmission will likely crack due to getting moisture inside of it that in the wintertime can freeze and expand. cracking the plastic housing, rendering the transmission completely useless. My customer said he bought this thing 3 years ago for around $2,000, so $1,500 for a transmission, $150 for a camshaft that requires you to remove and tear down the whole engine. And the model number for this particular riding mower is a YTA 18542. I just wanted to put that up there so you guys know which ones to stay away from. Now, I know this video is starting to run a little bit long, so I will share a couple tips and tricks that may help you guys start an engine that does have a broken ACR. Even with a fully charged battery, when you turn the key to start the engine, the riding lawnmower's electrical starting circuit doesn't have the amps needed to overcome that extra compression in the cylinder that was once released by that ACR mechanism. So the one thing you could do is hook up a battery booster that would boost the amps in the riding lawnmower's starting circuit. That would help overcome that excess compression. Or what you can do is, coming up to the flywheel screen here, put your hand on the flywheel and rotate it clockwise past the compression stroke. What you're doing is trying to feel that pressure build in the cylinder, and as soon as you get it past the compression stroke, then you should be able to start your engine. The theory here is that by manually rotating the engine slightly past the compression stroke, then when you go to turn the key, the starter can turn the flywheel and get it spinning fast enough to the point where the engine will now have enough momentum to carry it through that compression stroke. So let's see if we can get that to work. Works just fine. So without trying to start the engine, because it is in the shop here, I know this engine runs, but the engine cranked over just fine after simply rotating the flywheel to get the engine just past the compression stroke. Well, that's going to wrap up today's video. We didn't end up doing a repair, but like I said, my customer just doesn't want to spend the money for parts and labor. But with that being said, if you guys enjoyed the video, think about leaving me a thumbs up. It really helps me out. You can click here to subscribe and click over here to watch one of my previous videos. I upload every single week, so be sure to stop on by next week, check channel out for new content. And as always, guys, thanks for watching.